Hi, hello, this is your lucky sir. I am now with one wonderful reaction in IIT examinations, in NEET examinations. A repeated question will come from this Hofmann bromamide reaction. The questions are, in general, what are the intermediates in this reaction? And what is the speciality of this reaction? Here, the speciality of the reaction is, you can see this is amide. Amide is converted to primary amine, 1 degree amine. Here CH3CONH2, CH3NH2, one carbon is less. So you can call this reaction as carbon degradation reaction. When carbon number decreases, such kind of reactions you can call them as carbon degradation reaction. Carbon degradation it is. So see, bromine we are using. In place of bromine you can use I2, chlorine is also fine. In place of KOH you can use NaOH also. But in general, whenever you see, you can see Br2 and KOH. So amides, when treated with bromine and KOH, will be getting their primary amine. 1 degree amine is formed. One carbon lone, that's why it is carbon degradation reaction. K2CO3, KBr and H2. Sometimes some books you can see the number of moles of KOH also they ask. With for 1 mole of amide, how many moles of KOH is required? How many moles of bromine is required? Or what is the mole ratio? 1:1:4. These kind of questions also you can see in some materials. The mechanism is not actually known, but we'll go with the probable steps. See, in 3 steps you can explain. Step 1, this is step 2, and this is step 3. Okay, so bromine and KOH, when you are using, first this hydrogen is replaced and you are getting a bromine. So bromine is replacing that hydrogen. First step, this is called N-bromoamide. This particular compound is acetamide. This is one of the intermediates. Just now we are discussing about intermediates. This is the intermediate. Isolated intermediate. You can isolate this one. Now this is again treated with KOH. So you are getting there methyl isocyanate. Methyl isocyanate. MIC. कुछ याद आ गया आपको? Yeah, you are right. +1 में एनवायरमेंटल केमिस्ट्री पढ़े आप, याद रख लो. Okay, याद आ गया तो you just send me the answer. CH3NCO is formed, methyl isocyanate. Step 3, this methyl isocyanate when heated with KOH, you will be getting their amide. See, here CH3CONH2 plus Br2 KOH. This is I am cancelling. CH3NCO I am cancelling. CH3CONH2 right. Br2 right. KOH 2 KOH, total 4 KOH. KBr 2 KBr. H2O 2 H2O. K2CO3 and CH3NH2. So this is the balanced equation. In the balanced equation, for 1 mole of bromine, 4 moles of KOH is required. Remember, this is the first question. Then coming to the intermediates, N-bromoacetamide is an intermediate, methyl isocyanate is an intermediate, and some salts are also there. Okay, N-bromamide is an intermediate, salt of bromamide is also intermediate, isocyanate is also intermediate. See here one special word we are using, possible mechanism. We are not sure about the mechanism. The possible mechanism is, when you are using base means OH minus. This OH minus is attacking on this, so it is shifting like this. So nitrogen already with 1 pair, so getting this electron pair as a lone pair. Now nitrogen got lone pair extra here. This hydrogen and OH minus removed in the form of water. This K plus is as cation. So overall RCON 2 electron pairs, this will be getting negative charge. Okay, this is not plus, this is actually, I show you here, right. Okay, RCOBr, that is not plus, that is a bond actually. So this is the first one. Now this is the salt. Here we have written a salt of bromamide. This is bromamide, this is salt of bromamide. This salt of bromamide I am writing here. It is bromine is going out, K plus and Br minus KBr is out. So this part became RC double bond ON with two lone pairs. Nitrogen with two lone pairs, bromine has left with electrons Br minus and K plus, Kbr is out. This particular compound is called acyl nitrene. Acyl nitrene is unstable. This you don't take as an intermediate. Acyl nitrene. This acyl nitrene, once it is formed, it will be reacting with itself, that is called intramolecular rearrangement. Intramolecular rearrangement is very, very special. This electron pair is coming as bond and this alkyl group is attached here. R group with electrons, alkyl group is moving here to nitrogen. Nitrogen's lone pair of electrons are coming here. So it becomes R shifted here, attached to N. N is having double bond with carbon, carbon is having double bond with oxygen. This is isocyanate. Isocyanate. This isocyanate, when treated with KOH, it gives you amide. Amine, 1 degree, amide to amine, Hofmann bromamide reaction, carbon degradation reaction. In place of KOH, you can use NaOH. In place of chlorine, bromine iodine can also be used. Very, very, very special reaction. Its mechanism is not actually known. The possible mechanism is just now we were discussing possible mechanism. These are the steps, and the intermediates are these: N-bromamide, salt of bromamide, isocyanate. Isocyanate also you can take as an intermediate. Some books you can see the acyl nitrene also given, but acyl nitrene is actually unstable. But that is an intermediate, and these are the steps. For every 1 mole of bromine, 4 moles of KOH is required, and 1 carbon will be short in the product. That's it for the very special Hofmann bromamide reaction. Signing off, your lucky sir.